Here to support us, and yesterday evening by chance we met already in the lobby of the hotel.
Which we very much appreciate. So, welcome
Our colleagues, so it's Nigel Clark and Maria Oliette Ballester, right?
This one? Does it look right?
Thank you. So, good afternoon, everybody. No, we could try harder than that. Good afternoon. Very good. See, yeah, when you get the most difficult slot in the program, you have to kind of make sure people are awake. Okay, so my name is Nigel Clark. My colleague Maria will introduce herself later on. Technology, fantastic. So, yeah, I'm Nigel Clark. I work for the European Patent Office. I'm the head of the Patent Information Research Unit, which if you take the English word unit literally, it means one, and I am that one. So we're going to talk a little bit about our support and our activities with quantum technology and the quantum technology flagship. So far, we've been working with the flagship for about just over a year. And I just wanted to make a statement about some basics about the patent system. The patent system involves a bargain between the patent applicant and inventor on one side and the patent granting authority on the other. And that bargain says, look, if you want to have a patent right, the legal right to your invention, which means you can stop anybody else using your invention, you have to agree that it's made public. It's the deal. So this is all about a deal. And we'll be showing the impact of that deal during the course of this presentation. One of the consequences of that deal is that all patent applications get published. All quantum technology patents get published, which means that they can be found and individual inventions can be studied, but collectively they can give you a picture of the health, the growth, the development of quantum technology as a concept and as a discipline, if you like. So how did this happen? Well, we had started to produce what we call patent insight reports to promote patent data as a resource for innovation. You all read scientific papers, you all use the research results to help you find new research directions, to help you with your own research. Patent publications are the same kind of thing. They disclose inventions, they describe how inventions work, and very often you have the situation where the disclosure in a patent isn't found anywhere else. So what we've tried to do is to start publishing reports on various areas of future and emerging technologies to give an insight, and quantum technology is a future and emerging technology. Coincidentally, the European Commission was launching the flagship, and we thought that this was an ideal way to collaborate and have some parallel but concerted activities in promoting innovation. So we joined the flagship and offered and was interested in studying the evolution of quantum technology in its early stages as far as patents are concerned. So there was a match between the desires of both organizations to support innovation in quantum technology. So this is just an example from our report, our first report. We concentrated on second generation sensing and metrology. This is just an example of one of the technologies, an optical atomic clock. And so we started to look at the evolution of patenting in second generation quantum sensing and metrology. So this is what we were able to discover this time last year. And of course the field has moved on since then. But you can see that the number of patents in this field has started to grow. So from practically nothing in 2000, so a while ago, to at least 2017, which is when these data were collected, a significant growth in the number of patent applications. If you look at the distribution of those patent applications throughout the world, you can see that there's a country leading the pack, if you like. But as Jürgen Mleinek said this morning, there's an elephant in the room, and the elephant is in the corner there, as you see. And what it's all about is that, yes, there are a huge number of patent applications in China, but that's as a result of the Chinese innovation policy. I can talk about that in greater detail, but in essence, there's not a level playing field in the sense that the patent applications in China are essentially subsidized. So we need to look into them a little bit more detail to get a real figure. But if you were to remove the elephant in the room, then you see, for sure, the US is in the lead. But by the time you count up patent applications in Europe, not only at the European Patent Office, but in some leading active countries, then the figure for Europe as a whole is not at all bad. In terms of what we have done to promote that particular study, we were at the quantum technology launch in Vienna this time last year. We presented also at the Quantum Technology Conference in Grenoble in February, and also at the International Society for Professional Innovation Management in Florence in the summer. We've also produced a report based on that study, which is downloadable from the EPO website, and the link is in the slide here, so I assume that you'll get copies. If not, come and talk to us and we can point you in the right direction. And I'll just hand over to my colleague now, because Maria is going to explain to you what we can do and help you in the field of education, bringing the world of intellectual property, patents, and quantum technologies together. Maria.
Thank you, Nigel. My name is Maria Oliete Ballester. I'm Program Manager for Future Emerging Technology Projects and Judicial Training. Nigel has talked about studies, but we have already provided some training. And I wanted to briefly explain you why do we provide training and who we are. So within the European Patent Office, there's a department called European Patent Academy, and it is the external training arm of the office, of the organization, and it was created by the member states 50 years ago with the mission to promote and support education in all IP or patent-related IP for the stakeholders in Europe, no? And for the European patent system. And this is Quantum. The presence training that we provide is for over 2,000 participants per year. And we work with the principles of complementarity and subsidiarity. And that means that we have to work in cooperation with our national stakeholders, in this case with Quantum Flagship. The task of the Academy, European Patent Academy, and within in the academia area is to increase awareness of the European patent system, how supporting, as I said, with intellectual property lectures at universities and encouraging research activities. We also support innovation. We've heard that these 2 days by promoting and participating in education and training projects with designed for the industry and for the academia in the areas of IP creation, IP strategy, evaluation, and what we've discussed as well, IP management. We work with program areas. So I work with the academia and with judiciary, but I have colleagues who also provide training for other target groups, and that is NPO staff. These are representatives from national patent offices, industry and SMEs, and professional representatives. Professional representatives are the European patent attorneys. Yeah? So these are the 5 main areas we provide training: presence, e-learning, and also a lot of publications. How can we develop this support on quantum? Nigel will also say more about it, but for the presence training, we can give IP lectures, organize workshops, conferences, or training on lecturing on demand if you ask for it. We also have a research-specific program called Pan-European SEAL. We can give you details later on. And with this kind of association and networks that we have, we provide experts, IP sessions, or workshops as well.
Thank you, Maria. So one of the collaborations between our two departments actually resulted in a module that we developed, which we ran earlier on this year. It was focused on the subject area of quantum technology, but we ran through the basics of IP, IP applied to finding, protecting quantum technology inventions, and then the business management of IP-protected quantum technology in the marketplace. So this is also supported with background material and a sort of examination with certification. So this is something that we can imagine running again in the future. And evolving as the quantum technology space evolves as well. In terms of possible future activities, we could imagine doing similar pattern studies in the areas of quantum simulation, quantum communication, quantum computing. And I need to make a plug for the EPO. Our unique selling points are the fact that we can use EPO examiners to help us focus the research on exactly the right area. So we can focus on, say, quantum simulation. We know we can filter out first generation quantum technologies and concentrate on the second generation. Also, our data that we access is unsurpassed. Not only is it extensive, it's up to date, but it also has elements which I won't go into today, but actually data elements which are unique to the European Patent Office's data set, which nobody else can actually provide. So we also have analytics and analytical experts that we can bring in, so that from our point of view, the reports that we produce do have unique selling points that no other analytical service can provide. So the other thing that we really would like to do, and it's an appeal to the community here, we'd like to publish some case studies on quantum technology, typically from SMEs or university startups or spin-outs in the quantum technology space, featuring protected IP patents and showing how the IP has helped to develop the business. This is just the front cover of another report. It's actually about lasers, but it's really first generation quantum technology. So we would like you to help us to create a portfolio of case studies in this space. And of course, we're at an early stage yet. I mean, the flagship has got a long time to run, and as we saw, in terms of patenting, the volume is still relatively low, but it will grow. So as time goes on, we'd like to add to this portfolio. There's a couple of links in here that you might like to follow. There's access to online learning material. At the moment, this is quite general because we haven't focused yet on quantum technology, but we will. So you can download a lot of basic training or knowledge about the IP system and learn what it might mean for you in the quantum technology space. And also there's an alerting service that you can tune into that will actually tell you what's coming up. And when we get more quantum technology online, you'll be able to read about it in advance. So that's about it. It's my contact details at the end. So the organizers here, thank you very much for setting this up for us. They also have my details and Maria's. So if you want to contact us and follow this up, we'd be very glad to hear from you. But do think about contributing to the case study stories. Thank you.
So thank you very much for this very informative talk. I think we have at least 3 areas where we can cooperate. First, of course, is the intelligence. So how many patents are issued could be part of the KPIs of the overall flagship, of course. Then the training, we may think to, let's say, link training sessions from the EPO to our conferences in order to train young students or young researchers how to do the IP right. And of course the success stories, that's also something we have to do. So we have to communicate about successes, and if we can join up with the European Patent Office on successful individual patents and companies, that can only help us. So are there any questions to our colleagues from the European Patent Office? There is one.
Just the one.
I would like to give you the mic. Yeah.
I don't see.
Hi, could you please tell a bit the differences between national patents and European patents, and what will be the best strategy should, for example, a researcher in this area should put a patent at the national office or at the European level?
Very simply, in terms of the actual patenting, getting a patent, there's no difference. It's the territory in which things take effect. All national offices and the European Patent Office test for patentability in terms of novelty, inventiveness, and usability. But a national office patent is only valid if it becomes granted in that country. So if you want more coverage, you can go to different countries and file the same invention in different countries. The European system says, okay, you don't have to do that. What we can do is do a one-time filing, one-time search, one-time examination, one-time grant, and then you can decide which countries you want your invention to be valid in, or your patent. Strategy? It depends. That's one of these really strange questions. The assumption is that you, as a quantum technology company, organization, know your business. So you would know where the markets are. So the simplest strategy would be to file a patent application in your own country, and then you have 12 months in which to file patents anywhere else. So you could decide, for example, that there might only be 1 or 2 other countries that you're interested in, so you would file national patents in those countries. But if you see that there's a much wider market, then you could apply to the European Patent Office and then choose multiple countries in Europe. And I have to say that the European Patent Europe is different from the EU Europe. And we have more member states than the EU. So the EU has now 27 and a half member states or something like that. Who knows? But at least if and when Brexit happens, I shall still be in a job at the European Patent Office. So Britain will still be part of the EPO. But that's a strategy. But I'm only talking about what might be an ideal case. It's case-by-case basis. And you would have to decide what your best business option is.
So these questions may be part of such a workshop we were just talking about.
We could talk for hours about this, actually. So,
yeah. So do we have any further questions to the colleagues on the European Patent Office? If not, I thank you very much. Please give a clapping hand. And now we are coming to the last community feedback session. It's on education. I think the topic was mentioned, I don't know, many, many times over the last 3 days. And I hand over to Chiara.
This goes.
Okay, so thanks a lot. I'm Chiara Macchiavello. I'm from the University of Pavia in Italy and associated to CNR. And I coordinate the education activities in QFlag and in the flagship. So this last session of today is structured in this way. So I will first spend a few minutes just to recall what are the main objectives and the vision that we have for education within the flagship activities in the line of the strategic research agenda with respect to the education aspects. And then I will leave the word for a brief discussion of the actual education activities within the education working group to Rainer Müller. And then we hope to have some feedback from you, so to have some ideas, criticism, to help us understand if there's something missing, something to improve, and what is your contribution to all of this. Okay, so let me start. This is now already said many times. This is just to remind that quantum technologies is a very interdisciplinary field, and the training of successful quantum engineers and in general a quantum aware workforce is really one of the main objectives. This was already told within the high-level steering committee at the beginning of the flagship. So this, and we heard about this important many times in these days. So let me just say that actually the real concrete activities within the education in the flagship started in Grenoble, where we organized, well, there was a group of physics education researchers who organized a workshop within the Grenoble conference, which aimed actually at planning, teaching strategies that are based on the understanding of quantum technology. So this was the first time that really education was embedded in this very concrete way. And in this occasion, there was an education working group that formed spontaneously. And this was the first seed that helped in constructing the education research agenda. So this was the first document that was prepared by the education working group, and this was then made available to everybody online, asking for contributions. So we thank all the people that already contributed to it at this early stage, and that was the basis of what we have now in the strategic research agenda for the education part. We see that already here, that it's clear that if we want to have really a scale up in training and education, we need a very coordinated effort to do this in an efficient and serious way, let's say. And we need the collaboration actually of researchers in quantum technologies, of education researchers, and also of people coming from industries, because their point of view is very useful. So we really need this very coordinating action in order to implement all this efficiently. And let me just summarize the main points that characterize the education strategic agenda. So what we could identify is these three types of audiences that we have to address if we want to develop education, new education efficient for all levels of target audiences. So the first is at the university level, so this contains the students at the associate degree and bachelor level, the master degree and the PhD level. And also in this category we also included pre-service teachers, because of course this is also a category that needs education, because they are the ones who have then to teach to the younger generation, and academic staff. Then we have a second sector that includes all the industry workforce, so the current industrial workforce that is already employed by industries and maybe have a background that not cover quantum physics, maybe some quantum physics, but not quantum technology. So this is another important target audience we have to address, and industry decision makers. And then there is the third one, which we labeled as high school, which contains high school students and in-service teachers. So this is another aim. And these are the main aims corresponding to these three categories. So for the university category, we aim at developing a modern curriculum for future quantum technology workforce, because we really have to prepare the workers for the future needs. And for industry workforce, we will develop concepts to raise awareness of the workforce to current quantum technology and their potential, while for the last one, this in general includes the raise of quantum awareness for our citizens, so includes also outreach activities, and quantum literacy for future quantum workforce. So in this, it will be important to have new quantum curricular recommendations and new teaching strategies that are suitable to understand quantum technologies implemented already at the high school level. Okay, so these are our three main target groups, and this very quickly, we can just summarize the vision, the points that corresponds to the vision that we had. This is, let's say, a short-term vision within a time scale of 3 years. So you see, the first thing is to try to research and establish what are the needs and feasibility of a quantum technology curriculum at all the levels that we saw before, so from high school to undergraduate and master, PhD, and also the industrial workforce, resulting in a proposed quantum technology curriculum description and having some suitable teaching material and methods to cope with this. Then the formulation, this is connecting of standards to identify these quantum technology competencies at all levels. And then what needs to be done is also a repository of scientific literature, education studies, material and resources that can be shared and used by all interested partners. Then there will be, in this vision, a network platform with the establishment of regular national and international meetings that include, as I said before, this collaboration of researchers in quantum technology, education researchers, and people coming from industry to help us to understand what are the needs. And then there is a development of pilot program for master's degree in quantum technology and quantum engineers that are suitable to prepare for the offer of job in this field in the future. And this will be suitable not only for students who have already background in physics and quantum physics, but also students coming from other backgrounds that are important to train, like, well, engineering, maths, computer science, chemistry, and so on. And then, of course, we will address specifically the needs of member states and associated countries, and in particular of maybe of small countries who need to be coordinated with maybe countries who have more experience and already established means. So it's important to have this close collaboration among all the member states. And this, I can go very quickly, it's a vision in a longer term, so within a time scale of 6 to 10 years. So what we think are the main goals is a pilot program to implement this reformed approach of quantum technology learning in selecting member states for the 3 levels that we saw before, that it would include a certificate system in quantum technology and also a pan-European interdisciplinary quantum technology masters in quantum engineer. This with a component of leadership, industry, and entrepreneurial skill training. This we also saw that it's a very important ingredient for the future workforce, also to try to stimulate these entrepreneurial skills. And there will be an implementation of innovative research-based curricula for all the 3 levels, an educational approach for secondary schools and teacher education based on a modern way of teaching, which is actually has to be studied and developed, but it can be much more effective also in teaching quantum mechanics with respect to the usual methodology that is adopted at present by starting from the concepts of quantum technology and quantum information. This is something that we think it's also very important. Then to have joint international graduate schools, university activities for high school students, and also in this long-term vision, we think that it's important to try to have some recommendation and some plans to have education at primary level. So to start really earlier and earlier. This we also heard before that it's very important. And transversal to all this, we think that it's also important to have and to try to implement in education also all measures to address inclusiveness in any sort. Okay, so these are very quickly, just to remind what are the main goals and the main points. And this is a first concrete step that we need to do, so I would like to emphasize it also here. So the first concrete step is to try to collect the information on existing activities that are already going on in several member states, because we know that there is already a lot going on, but it's very fragmented among the various countries. So, so there are many initiatives that are not visible, and maybe we don't even know, we are not aware of this. So the first concrete step would be to try to collect all this and made visible also on the flagship website. This can be done with an online survey. An online survey was already launched in March this year, so via the flagship newsletter, but actually I must say that we didn't have as much feedback as we expected, maybe because it was at the beginning, many of you were not registered, so this is something that we are planning to do again, because we need to collect information also for future networking, future activities, and giving visibility at the same time to existing activities. So a new survey will be launched, but you will receive this information via the newsletter in, I think, a few weeks' time. And please, it's very important that you really contribute to this. Okay, so now I would like to have Rainer Müller here, who is one of the most active members of our education working group, who can tell us a bit more of the current activities.
Yeah, thank you, Chiara. Do you hear me? No?
Do you have an additional mic somewhere?
No? But now, yeah, when I stand here, you can hear me. Chiara was telling you what has happened already and what will be happening in the future. I will tell you what is happening right now in the education community. The field is pursued at the moment by a small group of people I would like to introduce to you. You have just heard Chiara Machiavello, who comes from quantum computing. Oksana Mishina comes from education. Me too comes from education. Jakob Schersen is active in quantum computing also, and he's also very active in outreach and gaming. Menno Feldhorst and Grazer Bastasin, you know from QTech in Delft. These are the people who are pursuing that program. It's pretty much a community effort. We sent that chart, the points that led to the chart, to nearly everybody we know who is active in the field. We received a lot of feedback on what to do in the education sector, and here is the results. If you start at the top right, or let me say, there are two main things to do: networking and starting pilots, coordinating pilot programs. If you start at the top right, we think in the next 2 years, this chart is about the next 2 years, what should be happening. We should start coordinating pilot programs at the 3 pillars Chiara has mentioned. University, the courses for quantum engineers, for physicists, for information scientists, whatever. Industry workforce for people who are active at the job right now and have never heard of quantum in their own studies. And importantly, we have heard it all several times today, at the high school level, we think there should be more quantum as it is right now in the European Union. As for the university sector, we want to set up working groups with members who are active at the moment or who plan to plan masters for the immediate future, and to commit themselves to share experience, to share materials, and to really learn from each other. Bring these people together and collect lessons we have learned from these experience, from these pilots, and so that future efforts can learn from the experience that were collected there. We also may identify a core curriculum, what it means to be competent in quantum technologies. As for the high school sector, the situation is at the moment very fragmented within Europe. There are countries, like Germany, for example, where quantum physics is an established topic in high school since decades. I had quantum physics in school for myself in a very traditional way. And now this development is quite nice. The German Ministry of Culture will be issuing recommendations for curriculum which are quite advanced really in the quantum 2.0 sector, like statistical nature of quanta or indeterminacy, complementarity, and so on. This didn't happen by chance. It was a lot of work for the past 20 years to get there. This is on the one extreme side. On the other extreme are countries, and I think that maybe the majority of countries in Europe where quantum physics in high school is no topic at all. And I think this should change in the near future, and it will change if quantum physics, quantum technology will get the attention we begin to see right now. And so we will be set up European working groups for the high school sectors where those partners who are not that far can profit from those partners who have experiences, and so not everyone should make the same mistakes repeatedly, so we can share our experiences in these pilot programs. On the left-hand side box is a graphic which represents the present status of education, academia, and industry. Academia and industry are pretty much connected in the actual flagship and drawn dashed lines to education. So one of the networking efforts over the next 2 or 3 years would be that we can replace that with solid lines. So the education community is tightly linked to the academia and industry. And things are really changing right now in the education sector. We begin to see the flagship really acts as a catalyst in this community. So there is a new topic which is very hot, and we begin to see groups emerging in different countries which will focus on quantum 2.0, on quantum technologies. This has happened in Italy. 4 or 6 weeks ago, there was a convention of Italian education scientists. It has happened in Germany already, where about 8 groups are active in that field and have grouped together to make a combined effort, and we will see it in other countries soon. I've heard there's an Eastern European compound that is about to form, and this is happening at a pace which I would not have believed 1 year ago. Like I believe Tommaso was saying, in some areas here it is the same. The field is really changing at a rapid pace. And well, in the middle you see what we are planning is an European competence framework. What is a competence framework? It is something that maps out the whole field of quantum technology. What does it mean to be competent in quantum technologies? What competences can you acquire when you studied quantum technologies? We've heard this in the panel this morning. And we will make a study, ask everyone from industry to academia, what do you think a quantum engineer or somebody who has quantum physics at high school should have learned? And then that gives a big map of possibilities at various degrees of complexity. And we will formulate a competence framework, or at least a draft version of this, after a blueprint which already exists. The EU Commission has issued a competence framework for digital competences in education. And this is quite nice and handy and easily understandable, and it already exists, so we will model it after that blueprint. You can have a look at it. It's called DIC-Comp Edu, and it's quite nice. Yeah, the next thing in the small charts is Carol mentioned already, is to have an infrastructure service upset, so that we collect just what exists at the moment, so that in this fragmented area we have one place where all the efforts are connected, just to get an impression, an overview of what is happening. And in the end, hopefully it will happen that we have a pan-European program where we have now fragmented national efforts in quantum technology. This is my hopeful view of the field. Yeah, I forgot something. Yeah, one thing I would have to mention. In the European community of educators, we have been forming a working group. The relevant association is GREP, and we even have GREP representative Sergej Faletic present. He was also present at the Grenoble conference, and maybe he can say a few words about the education community and GREP.
Maybe just quickly.
Okay, here I am. My name is Sergej Faletic. I'm representing the GIREP organization. GIREP stands for International Group on Physics Education Research. It's a French acronym. The president right now is Marisa Michelini from the University of Udine. And immediately after the conference in Grenoble, she launched a call to the GIREP members and the sympathizers to form a community on teaching and learning quantum physics. The community is now has been formed. It's made up from about 48 members right now, and it's increasing. Many of the European member states are represented in the community. Some, those in orange, are not yet represented in this community, but that might be, Finland is one of them, but that might be because the call didn't come to any groups in Finland. There are also member states, so members from states outside of the European Union, naturally, because GIREP is an international organization. Now, the main focus on GIREP is general physics education research. So in the context of quantum physics, we are aiming at basic quantum education, which would be in the lines of physics, like, what was it called? Physics, the quantum literacy, in the sense of quantum literacy. But among the presentations, we already had a symposium of this group in the last GIREP conference in Budapest this year, and we discussed these topics. These were the panel presentations. And you can see quantum cryptography as a possible approach to teaching quantum physics, which is related to quantum technology. But there are also the more traditional approaches like two-state systems and wave functions. We had also a discussion workshop where we discussed the various approaches and what are the main topics that we need to teach to students in the field of quantum physics and quantum technology. And here we would very much welcome the input from the quantum technology community, because we have an idea of what quantum physics, what are the basic, the crucial components of quantum physics. But quantum technology might require some additional or different elements, and here we would very much welcome the input from your community. And basically, what I wanted to end on is that there is some, that we have already discussed some basic important topics, like those are very related to the specifics of teaching quantum physics, but among these are the experiments and the applications, and those are very related to quantum technology. And it has been also pointed out that even in classical physics, technological applications are very important for motivations of students, and it is certainly the case also in quantum field. So it is also the case that quantum technology might be a good catalyzer. Moreover, I would like to say that the quantum flagship has enabled us to push a little bit on national governments to introduce quantum physics into high school curricula in the countries where it has not been done yet, because now there is a strong international European support for this, and it might get things a little bit moving. So I would like to thank the quantum flagship for this opportunity, and I hope we can provide you back with some valuable input on how to teach and how to bring this educational part of quantum technology into the high schools and maybe even in the elementary schools. So thank you very much.
Okay, so we can I hope you had an overview of the activities, of the ideas that we are thinking about. So we would like to have some feedback from you, feedback in the form of criticism, or if you see that there is something missing in this roadmap, if there's something that can be improved, or if there are experiences that you are already doing within education or within industry that could be helpful for us for this plan. So, I mean, any really feedback contribution is really welcome. Yes?
Like our president Ilkka Nieminen said yesterday, that we have a program in quantum technology, a bachelor's program, or actually it's a major in the international bachelor's program. It's a major in quantum technology, and I have been there, and Ilkka back there, that we have been kind of developing the curriculum recently, and we thought that the bachelor's level is actually quite good place already to start it, because that's when the students come to the university, and they are kind of hungry for new information, and if they have to wait to the master's degree level, I think we may lose some good talent. Indeed. So that's one of the reasons why we started at the bachelor's level, but also you need a lot of other sort of background, obviously, not just quantum physics. And also in quantum technology, it's a very broad field. Like we've seen here, we have, you know, the superconducting circuits, we have silicon, we have photonics, that I think that these programs, eventually, they need to focus to some extent. Or then you should have program in photonic quantum technologies, program in semiconducting quantum technologies, for example. Maybe that would be in the master's level, or maybe that would be just a major or minor. But just to bear in mind that to grasp the whole quantum technologies is a very challenging task, and some sort of focus, I think, is good.
Yes, thanks a lot for the comment. Indeed, the focus depends also on the levels you are aiming at, because I think that if we think, for example, at high school education, then the main thing is to try to, transmit, let students understand what are the basics. Of course, you don't go to a particular platform. This is something which is foreseen in a more specialized, like a master course and so on. But we tried, as you said before, I mean, the plan is very broad, but we wanted to take this challenge because we think that it's very important to try to at least think about the best way to put some seeds at all levels. And we are lucky that, as you saw, we have the support of the physics researcher, education researchers who are really in contact with the high school teachers and students. Then we have the academic staff who is usually work with the undergraduate and master PhD students. So we have the support of this various community. But no, thanks for the comment. It has to be taken into account depending on the level. Yes?
Frank Wilhelm, I think I've talked already a fair bit. First of all, congratulations. I mean, I've only been close to this program since Grenoble. I thought Grenoble was amazing, but it has been continuing really, really well. I think one thing where I would like to relate a little bit to what Mikko has said, which one should keep in mind, is that some of these things move at extremely different speed. I mean, I think the speed of curriculum change is probably roughly like the speed of a glacier. However, specifically, these new university programs are often established extremely fast. So we were thinking after Grenoble that we should start an undergraduate program in quantum engineering at Saarland. And that was 6 months ago, and the first students just arrived, so we have it. And I think it's then important to keep in mind that bringing all these programs together is also an opportunity, because there you get very quick feedback. So changing a university curriculum is much faster than changing a school curriculum. And I think it's kind of a good laboratory to check how students respond to new programs when they enter university. And I think a lot of people in the academia are extremely excited also to probably help you, because we tend to be frustrated on how bad high school students are. So I think keeping these different speeds in mind is important, and I can echo what Mikko said, is that also take the fast movers as a resource.
Thanks.
Thank you. Tony Apolago from University of Malta. First of all, I apologize because I missed the first part of the discussion because of another commitment. So my question, something that I say may have been included before, so I apologize in advance. My question is this work group on education also dealing with dissemination and science communication? Because, I mean, this is one of the fundamental topics, according to me, for the flagship and for its continuation as well. Because one thing is to form students, technicians, engineers that work in industries, that work in academia, that work in... But if and when the deployment of quantum technology comes, it has to face also society. Say, if one decides to use cryptography for political elections, there will be a lot of people that did not hear nothing about quantum cryptography. And in order to be accepted, there has to be a quantum awareness in all levels of society. So what are the plans for this? Because for what I've seen, it's mainly school and university oriented, which is a very short segment of the life of a person. Thank you.
Yeah, no, indeed, I mean, this was not stressed here. It was more focused on the education at these levels that I mentioned. But indeed, there is also a plan to include also the outreach, so really this dissemination on society, and to have a working group also specifically addressing these needs. Yes, within the education plan. Yeah. Thanks for reminding this. Maria? Yeah.
Sorry, voice is terrible today. So I'm Maria Bondani. No, it's impossible.
I'm working at University of Insubria in Como, and ever since before in Italy, the ministry decided to include quantum physics into the schools. We made experimentations with the teachers, and it was even best before than now, because now they fix the programs, and the only quantum physics which is included in programs, and which is compulsory for the final exam, which is the main issue for students and teachers, of course, is the final exam, is those pre-quantum physics, which has nothing to do with quantum technologies. Well, it's marginally something to do with quantum technologies. What we are doing now, this year is the first year we will experiment the teaching of true quantum physics in curricula, because what is many experimentations are on in Italy, but for just selected groups of students and selected group of teachers. What we want to do is include something of true quantum technologies in school for everybody, because what I think is that it's an important cultural issue for everybody to know what is this new technology, to know what does it mean having a safe cryptography or cracking codes or something like that. So this is what we are trying to do, and I hope next year I can report on a success or on a failure, I don't know. Because of course the challenge is important. And I think that your point on dissemination goes on the same direction. We have to talk to children and to parents simultaneously to make all the society aware at the same time. Because, and I think that the exhibition we have downstairs and also other things that have been done in Italy also can be put together to make a sort of portfolio of activities that can be spread all over Europe to help people that has no possibilities or no fantasy or need help somehow, and being helped by German people who have long-standing experience. So I think we can work together, putting our experience together.
Thanks a lot. Yes.
Hi, Victor Land. I'm curious, I think demonstrators can really help to make things tangible, like the ones downstairs, for instance. Is there a role, for instance, for science museums in your program? Because they can, I think, really help connecting education and society through demonstrators.
Yes. No, this is something that we would like to reinforce. Actually, we have a plan also with the quantum gains that we saw yesterday downstairs with Sabrina to have a broader plan about it and to try to connect several universities working on a bigger activity of this sort. So, and hopefully build something that can be then exportable and used by other institutions and by other teams, other countries. So this is actually very much online in what we would like to do, and it's a very interesting tool, as we saw. Yeah. So is there any feedback from people from industry? Because this is also something that would be very important to us to get some networking and understand from the industrial point of view, both from the point of view of understanding actually what are their needs, and also for networking with the aim of setting up these master courses with internships at industrial players for students. So it would be very useful. Maybe now there are not many industrial representatives, but if possible to have some contributions also from this sort. Yes?
Yeah, maybe I can. Jari Karu from Finland. I'm from Kone. We are building elevators and escalators. And maybe, I don't know, just the overall course on the quantum things for the business decision makers, for them to see the potential, those kind of things. And then also, like I said, I'm not an expert on the quantum things, so just a kind of a basic course, how things work. Yeah. And when they could be applicable for us.
Yeah. Any other feedback, comments, or suggestions? Do you see anything else missing in this or? Okay, otherwise, okay, thank to everybody anyway.
Okay, thank you very much, Chiara. So, So we are nearly at the end now. Thank you very much for being here until this time. So I know it's Friday afternoon. We have a last, well, not a presentation, but a last small remarks from the European Commission on the last 2 days. So I would ask Pascal Maillot to come on stage and just share his thoughts. Oh, you need a microphone, right? Or you probably can just use that one as well.
Do you have a...
No, I don't have.
Okay.
Just some comments. Yes, you can hear me? It's fine? Okay. So the pleasure for me to make the closure of the event. I won't make it long because I've heard that lots of you have a flight at 6:30, so I guess you have to rush soon, but it won't be long. But it will be good because I was very happy of these 2 days. I would like to thank the organizers of these meetings. I know it wasn't easy to gather 260 people to prepare all the speeches and panels inviting people of a certain level in different organizations. And it was done. And it was greatly done with great conversations about different domains of the quantum technologies, fruitful exchanges and remarks and questions in the audience. I would like to thank also all the participants from different world, academic, industries, policymakers, different fields of intervention, and different fields needed for the development of quantum technologies in Europe. Because this event that we have had today, last 2 days, come after some presidency event or quantum event, quantum workshop that we have had since 2016. The message about the flagship, the quantum flagship, mentioning the development of R&D and the lab to market has been passed several times, and I think now understood by the community. And this was one of the objectives. But this quantum flagship is not closed on itself. The quantum flagship is R&D to develop the new technologies, the products that we can use in quantum technology, but it's not closed because now it's opening to the world of infrastructures. Application in infrastructures, we have mentioned since the beginning, it's lab to market, and now quantum technologies, I strongly believe that it's really the time to go to market. And with the infrastructures, I would like to mention 2 big initiatives, or remind, because it has been mentioned during these 2 days, the QCI, the quantum communication infrastructure that we want to deploy in Europe with a ground segment and a space segment. The declaration of support for this infrastructure was signed by 10 member states, or have been signed by 10 member states, because we hope that we will reach very quickly 15, and let's hope 27, not to quote Tommaso, I don't remember 27, 28, but I guess the last news is more around 27 now. And the second infrastructure that we will develop a bit later is the quantum computer infrastructure. It was explained by Khalil, some quantum computers in Europe open via the cloud to the quantum community, the researchers, the industries, and the academic. So, as I mentioned, more or less we expect 15 member states for the QCI. When you go back home, please give the message. We are still missing countries. We are still missing involvement from some member states. So from whichever field you come, academic, industry, or policymaker, please pass the message to your authorities. H2020, the program for the Quantum Flagship, will finish in the coming months. What is important for us and for all the community is that the Commission has already said, and the President-elect Ms. von der Leyen has stressed that the quantum is a high priority for the Commission, for the new Commission, which is not established yet, but it will be a priority for the next Commission. And the name of the program will be Horizon Europe. It has been mentioned also. And this is a strong indication that it's a priority and there will be money for Horizon Europe. The development of the infrastructures, the application of these quantum technologies will go under the Digital Europe program. You have seen, Khalil showed a slide, a third of it to high-performance computing, a third to quantum technologies, and a third to AI. So quantum has a really strong place in the future of the budget for quantum in Europe. Now, I've talked only about public money for the R&D, public money for the QCI, to develop really the market in Europe. But the public money is not enough and will not be forever to build the ecosystem that we would like in Europe. So then it's up to the industries, to the venture capitalists to engage the money in the market of quantum. We will give the push with public money and then up to the market to go on to develop further the quantum technology. So I count on the VC, on the startups, on the big industries to go on for the development. Industries should and must be more and more involved, and even students could go to the entrepreneurial instead of going to a lab, even if I guess some teachers here would not like to hear that because they want to keep their best students. But we need entrepreneurs also in Europe. Now, when I say development of the ecosystem in Europe, we shouldn't be naive, and it's very important that we protect our interests. You have seen some examples in the press. As I'm representing the Commission, I will not make any diplomatic issue by mentioning them, but I think you all know what I think about. And leaving the scientific field to go to the market with business, with money, with competition, of course, will attract lots of players. And let's be very careful that we still protect our European interest. However, protecting our European interest doesn't mean that we go back to 3 centuries ago and each country works only in a close bell. There was a panel for international cooperation, lots of discussion, really interesting points were mentioned, and international cooperation is still very important in the continuation of this quantum technology development for the Commission and for the EU at large. There were already some international cooperation workshop with USA. We plan to have one with Japan at the end of the year, and Canada also is in the list for next year. But here also, as mentioned, we shouldn't be naive. We must work on a win-win situation for both parties in this cooperation. What can I say more? I think I arrived at the end of the different points. Marcus, if I forgot something important, tell me, and I will try to make a smart sentence.
You continue your support for the flagship. I think that's the main message we take home. And with that, I think we will start now. We will stop now the event. So we hope that you will all have a safe trip back. Thank you very much for coming. And yeah, have a safe trip back.